All right. So whoever is uh like new here, I'm just going to like the whole purpose of this is just to like document whatever I'm working on, and I'm gonna try um I'm gonna try working on an open source project that I worked on 2 years ago, and the purpose to summarize what it does basically. Uh, I'll just read what it says here. Sensor Matrix is a software platform which will take the data from different portable biosensors as input, automate the pre-processing, plot the data, display basic metrics, and give the user the ability to run the signal processing operation commonly used in analysis of electrophysiological signals. So if that doesn't make sense, basically, we take in data from different biosensors. So it can be like an Apple Watch that'll measure your heartbeat, uh, or like something that'll measure uh, your heart rate. That'll be strapped to your arms or something. Um, and then it'll process the data and kind of plot it in a way that's like easy to understand. Um, and on top of that, what I worked on after was the ability to find any anomalies. So if there's something wrong in the heart rate, for example, it would tell you a snippet as to what time frame the problem happened, and it would give you with the percentage uh, what what the problem could be. Um, so that's like a little high level overview of what it is. I have a lot of documentation as to like how to use it and things like that. Since it's been like over 2 years, uh, since it's been 2 years since I worked on it, I'm just gonna for this last year, I'm just going to kind of see if I can at least run the algorithm, like run the program, and from there on, I want to make changes and make the program better. And I'll talk about what I want to do probably in another time. So this computer is a Mac, so I'm just gonna follow the steps that I already wrote and see if I can get things started. So for one, they're saying I have to install Python 3.5.4. So probably that's one thing I would want to update, make sure it has the latest Python. So I'm just gonna see if I can download it. So Python 3. All right, and I believe I'm 64-bit. I just realized that you guys didn't see the screen the whole time, so I think it should work now. Just gonna test and see if I can see it on I need to, if I look at it, yeah, it doesn't look that readable, so let me see if I can move myself. Alright. Alright, sweet, it works. It's my first time doing this, so sorry about that. So yeah, so I installed Python 3.5.4. I'm just waiting for it to be done installing. In the meantime, I need this uh, classification model. So that's basically what's used to decide, like based on what the heart rate is, it'll tell you what could potentially be the problem. So it's like a classification model, and I just can download it. It's a pretty big file, so yeah, downloading away. Alright, so that's downloading, and let's see if Python's done. So Python's almost done. Um, so in the meantime, let me just clone this repository. So alright, so I already have it. Let me just call it master, and we're from there. Alright, so that's good. And Python's done. And that's trash. Okay, so that's good. Now I can go on with the rest of the installation. So it's saying I need to install HighEnd. That's right, PipEnd. So what PipEnd does, it kind of makes different. Yeah, PipEnd basically makes like a virtual, kind of like a virtual machine. So it'll keep track of all the, so like whatever you install for whatever packages you install, it'll be kept only on that virtual machine. So basically, let's say you're working on another project and you need different packages and different versions, it won't like interfere with that. So that's PipEnd. Yeah, so I'm just installing that. Let me see if there's anything else I need. I think I'll need some test files so we can actually view something. So I'm going to remember the website that contains all DCG, like a bunch of DCG data. Let me see, DCG data online. Oh yeah, so it's called PhysioNet. And here, just a database of a bunch of files, like a bunch of like biosensor files. So something like ECG. So in English, basically ECG is like it measures like your heart rate, and EEG it measures your like brain waves. Uh, those are the two that I worked with, and I'm more familiar with ECG, so I just find something for ECG and just like that. Trying to find one that I remember. It looks a little different from last time I came here, so things take this. Yeah, so those are the type of uh, a format for how they record the ECG files. .edf. There's a bunch of others, and we basically allowed the ability to read these kinds of files. So I'm just going to download this one, see if it'll work. Oh, and we got the model. It was downloaded. And let me see if PyPen is done. So yeah, can continue. So can continue on. Okay. Hmm. Okay, so things for reinstall PyPen, it would work. Can see if that fixes it. All right, so once I download the file, I have to make sure it's in I believe the root folder. So I'm going to move that. So I go to, all right, I go to my name, then I go to dev, and I go to central core, and I think I just place it in this. All right, so that part's done. And let's see what else. Okay, PyPen is still installing. And the purpose of this video is just like document things. Like as I'm going along, I want to document all these stuff. So that's why I just decided to make a live stream out of this. Yeah, taking a lot longer than I thought. So I also wrote this document. Let me see if there's anything else. All right, yeah. So I recommended whoever wants to write on this to use PyCharm. It's an IDE. Basically, it puts all the code together in one place, and I find it pretty clean. I'm not sure if I have PyCharm here. No. So I'll just stick with using VS Code for now, and maybe in the future I'll use PyCharm. But this is going to give me ideas that I should be making releases that you can just download the application. Um, that would probably make my life a lot easier, and for anyone who wants to use it instead of doing all this crazy stuff. Okay, so still downloading. Let me see if there's a way I describe how to load the data. Oh yeah, so I specify here what kind of data formats we allow. So yeah, we allowed EDF, FIF, JSON, and text files. Yeah, I'll go over all these things. Oh yeah, I can even get directly from the website. So I'll try that out. Once this is done. Oh yeah, so this is how the website used to look like. It looks a little different. Uh, yeah, it looks. Alright, so we need to simulate the data. Alright. Hopefully this works because it's taking a while to download everything. I guess I can go over some things I want to fix. So these are things I wrote. Well, actually, these are things I wrote a while ago, and then this is what I just wrote earlier today. So for one, there's no unit test at all, and I feel like having code with no unit test can result in like problems down the road, especially the fact that going back and writing things now after 2 years, I might not realize if I break something or not. So should definitely start to add unit tests. Another one was anomaly detection for EEG. So remember how I said how we can find um, find problems or detect problems in uh, heart readings, like heart rate readings. We don't have that for EEG, which is like the brain waves. Um, it was something that I found was pretty complicated, so maybe I can put some more time and research it to understanding how we can do this. This one, think about how to get audio files. I'm not quite sure what this meant. Maybe I described. And I get no description, great. So I'll probably have to close this or maybe think about it later. What I might have meant. This one, fix dependency issues. I've been getting like these dependent bot alerts for a while, and I thought it might be time to fix them. So that was one of the issues. And the final one was I wanted to create an engine for the core algorithms that I use. The whole purpose of this was just because since everything is written just as a GUI, like basically it's a GUI in the end. Like you can see, yeah, like this is like the GUI that we made in the end. It would be nice if I can extract all the core algorithms, and that way we can make this stuff maybe in a web application or even in an app, or yeah, that like it'll make it a lot easier to move like the front end to somewhere else. And those are the issues that I wrote. Maybe by the time it's done, it's still not done. Well, okay. Okay, I guess we'll do it. Maybe I'll even talk about the backstory of why I made this. So this is actually a capstone project, and if somehow for a capstone project, basically is when you want to graduate in engineering, you have to like make something, and it'll be evaluated, and if it's good, you'll pass or fail, and that's like a requirement for us to graduate. So this is what we decided to, what I decided to work on. Um, and then uh, after it was even, after I finished this capstone project, my supervisor for this project wanted me to actually continue working on this, because they found like potential use of this. Uh, the reason, uh, the backstory as to why this was needed is because there, as you've seen, like there's different uh, um, like file formats that'll store the biosensor information, and there's no real way of, there's no like standard way where all these uh, formats are put into one and displayed. So, like for example, I believe if you wanted brainwaves, you would have to download this other. You would have to this um, buy this service, where whatever the brainwaves is, you would have to buy it, and then you can actually view the results. Whereas the whole purpose of this is to kind of make it free and open source, so other people can contribute it, and whatever uh, whatever biosensor information they have, they can view it and do like processing and analysis on it for free. Um, and yeah, I just the reason I stopped working on this was because of school came up and everything. So I just thought I would finally come back and kind of contribute on it, and maybe make it more, make it better so someone can actually use it. I'm not sure why it's installing all these things. I just want to pip in. Alright, um, so now I can do this line. Let's see. Alright, doing stuff. So right now it's installing all the dependencies. And I wrote that in this zip file.lock. And basically it's just downloading all the things given in here. Let me just make sure. Yeah, so just download these guys. See how's it doing. Alright, downloading. And then after that, I have to do pip shell. Pip shell basically activates the virtual environment. Alright, almost done. Alright, so prevent shell. Will work. And all I should technically be doing is this. Let's see. Oh, doing something. Oh yeah, it works. So this is what the icon that we made when it's loading. Alright, so it's telling you what's happening. Maybe even I can make the loading screen the time faster because it's pretty long. Oh, bunch of gibberish. Alright, so it's slow works. So I'm going to try loading something. And alright, so this is the database you can get. Let me see if I can get something. See what happens. This should bring us to the website. Yeah, and they definitely changed it from last time. Let me see if I can do ECG. ECG quality, okay. I'm not sure if I'll still be able to download it because it looks a little different. Probably won't work. So I'm gonna try doing it locally. Yeah, so it has a folder called biosignals. Let me see. It automatically get created. So I just have to basically drag what I found to that one. Let me see. Okay. Now let me try doing it again. So I click open. Loading. Alright, so it worked. Okay. So here, these are the heart rate. And here we can actually like view specific components. So like as I kind of go through it, move it along, I can see like the spectrum view. Kind of forgot what was the point of these, but yeah. But yeah, so that probably works. It's awesome. And these are also heart rates. Trying to see if there's anything else I can just demonstrate. Um, yeah, I think these are all that I remember. I guess I can move this time. Uh, just tells you what time though. Oh, great, I lost it. So that's a bug I can talk about. Oh yeah, and this just able to go through each of the go through the time. I remember the ability to find anomalies. I can simulate something. Let me see. See if I delete these, what happens? I guess I just manually delete them one by one. That's about what we'll talk about. And delete. Alright, so these are the heart rates that I can make. I can do a bunch of things with them. Let me see if I create the signal. Alright, so this is a classification. So this kind of like takes a snapshot. This is the algorithm working. The machine learning algorithm takes a snapshot of each heart rate, and then it'll just try to classify what the problem could be. So let's say here, yeah, it tells you normal B with a probability of 100%. So it thinks it's normal. Let me just show you one with an actual problem. So let me modify this beat. So these parameters can like change the, yeah, they can change the, like how it looks. Let me see. Yeah, and these little waves, so they kind of define what each of these waves mean. So I believe it's P, Q, R is this big peak, then there's S, and T would be this one, I'm guessing. So let me see if I can modify the R wave. Yeah, so as you can see, I can shrink it. Let me make this wave smaller. Oh, make it bigger, sorry. So you see it's getting bigger. How about that? It's getting bigger. And I can even move this T wave further closer to me. Oh, and yeah. They're all the same. I think I might have messed it up. Let me just do it again. So make the R wave smaller. Make the S wave larger. Make the T wave maybe smaller. Oh, whoa. Oh. Let's go back. Think probably great. Okay, I'm gonna do one more time. Let me just write the value itself. I'm gonna write to 0.0125. Let's see what happens with that. Oh no. Great. I just made it. Oh, interesting. So it looks like I didn't modify it, and it's telling me that with a probability of 100%, that it looks like the problem could be premature ventricular contraction. So let's just see what that actually looks like. Premature, what is it? Ventricular contraction. Let's just see what it looks like in an image. So it looks like there's a bigger dip with I forgot. I think it's the S wave. And yeah, that does make sense. So you can see that the S wave has a much bigger dip compared to the usual. And yeah, so it looks like I was able to run the program, and that's good. So from here on out, I'm just gonna make changes and where the actual coding is gonna start. Yeah, thanks for watching. Have a good day.